Okay, this video is for the atomic structure notes in your binder. So if you were absent or you just want to look at this over again, you can watch this video. Okay, here we go. The term element, so the word there is element, has multiple meanings. So it can refer to a type of an atom, a sample of a substance, or a substance in general. Now, elements are on the periodic table, and they have symbols on there. Now, when you see the symbols on the periodic table, the first letter is always capitalized, and if it has two letters, like sodium, the second letter is lowercase. All right? Now, some of them, like for example, sodium is Na. It doesn't start with an S. S is sulfur. So look at the names if you're unsure. Here's a few that people commonly confuse. All right, now, one of the main things that you need to know in this unit that we're going to talk about is the subatomic structure. And so the first thing that you'll want to know is the structure of an atom. So I'm going to draw a little picture over here. And in the center of the atom, okay, the center of the atom, that's called the nucleus. And in the nucleus, we'll go through this in a second, there are protons. I'm going to put a P with a plus, and neutrons. Those are both in the nucleus. Now, a neutron gets a little zero because it's neutral. So in the nucleus, there are protons and neutrons. I would draw that picture. Now, outside of the nucleus, this is a little complicated to draw. This isn't really exactly what it would look like. But anyway, I'm drawing this. This outside of the nucleus is this empty space, or mostly empty, okay? And it's called the electron cloud. And in the electron cloud, you guessed it, there are electrons. They're outside of the nucleus in the electron cloud. All right, so I'm going to go through these notes now. So protons, they have a positive charge. That's why a lot of times when people abbreviate it, you can abbreviate it like this, P with a plus, proton positive. See how they both start with a P? All right, so a positive one. And that's located in the nucleus. Now, it has a mass. This AMU stands for the mass. Okay, now one of the most important things is the atomic number. The atomic number located on the periodic table. So if you see a periodic table, let's say we'll just look up lithium on the periodic table. And lithium is number 3. You're going to see a whole number at the top. Okay? That is the atomic number. You'll see that on the periodic table. Okay? That's also the number of protons. Okay? And then down here, down below, 6.941. That's called the atomic mass. So you might want to make this little key just so you know. Atomic mass. But this is the important one right here. Atomic number. That is equal to the number of protons. All right? Okay, electrons are located outside of the nucleus. We kind of already talked about that. They're located in the electron cloud. They have a charge of -1. Now, this says no mass. That's really not true. It's really, really small. Okay, it's a very small mass, like it's 1,840 times smaller than 1. So it's like 1,840 times smaller than a proton. Okay? Okay, neutrons, they have no charge or neutral charge. Okay, that's why a lot of times they're abbreviated with an N0. There's a different way to do it, we'll learn later. But they're located in the nucleus. They also have a mass of 1 AMU, just like a proton, okay? Now they help keep the nucleus together. Sometimes they're called gluons, so I'm going to say glue the nucleus together. Okay, not all atoms of the same element are identical. We'll talk about that later. Okay, here we go. Atomic number. It's the number of protons. This is very, very, very important. Okay? So, for example, carbon, if you looked up carbon on the periodic table, you would see that there's a number 6 up here, and there's like a number like 12.011 or something like that. This number 6 is the atomic number. It's also the number of protons. Mass number is number of protons plus neutrons. You're going to want to write this down. Mass number equals protons plus neutrons. And if you add those up, you get mass number. Okay, for example, let me give you an example. Like, let's say there was this thing called carbon-14, and we're going to learn how to do this later, but in a second. But carbon has 6 protons. See, I know that up there. It has 6 electrons, because protons will always equal electrons in an atom. Now, the neutrons are going to be 8. Now, the mass number then, if you take protons plus neutrons, 6 plus 8, that's 14. Okay, you don't add the electrons up. 6 plus 8, 14. Okay, and that's also how atoms are named. Okay? We'll talk about isotopes later. All right, there's 2 ways of writing atomic symbols. Okay, now the way an atom is named, it's by its mass number. Atoms are named by the mass number. So that 7 in this example represents the mass number. Sometimes it's written like this. There, I'm going to write it over here. 3, 7. And that's a different way of writing it, but that top number is also the mass number. Okay? So there's 2 ways of writing it. Most of the time they don't put that dash line there. Whoever typed it just did it because it's hard to type it. Okay? So for example, carbon-14 is my example I used earlier. You could write it carbon-14, or you could write it this way. Carbon, its atomic number goes at the bottom, and the top number is the mass number. So this is a good thing to make, one of these, just so you know. The bottom number is the atomic number. The top number is the mass number. That's something very important that you'll need to know. All right, let's go on to the next page. Now, there are these Venn diagrams you have to be able to complete. Okay, in order to complete them, you got to remember a couple things. First thing that you got to remember is mass number equals protons plus neutrons. Okay, so you'll need a periodic table to do this. So grab a periodic table and look at it. Okay, now if you find the symbol K on the periodic table, you would see that that's number 19. And remember, the 19 is the atomic number, but that also equals protons. So that's another thing you got to remember. Atomic number equals protons. So that's why K is 19. The next thing is protons always equal electrons. So 19 and 19, they're the same. Okay. Now, to get the neutrons, here's what you got to do. Okay, what I like to think about is electrons don't matter when you figure out the neutrons, but protons do. So we're going to use this formula. Protons plus neutrons equal mass number. Well, the mass number is 40 because that right there is the mass number. So 19 plus some number of neutrons has to equal 40, and that number will be 21 because 19 plus 21 equals 40. Okay, let's try another one over here. Okay, now another way to write these symbols, and I like this way better, because I'll show you in a second. So it would look like this, nitrogen 16. The reason I like it this way is because number one, you don't need a periodic table because right there, that bottom number is the atomic number, and that bottom number always equals protons. It also equals the electrons. Okay, now to get the neutrons, remember electrons don't count. Okay, but here this way it's already set up because if you take the mass number, subtract the protons, you get the neutrons. So 16 minus 7 is 9. And so when you write it this way, it kind of makes it set up to do a subtraction problem already. Okay? You got to know that really well. Okay, the last thing is atomic mass. Okay, atomic mass, and this is something I'll have to talk about in class more. It's the weighted average of the masses of the naturally occurring isotopes. It's a weighted average based upon percent abundance, which means which one's more common. So let me give you an example. So let's say you had some lithium, okay? Now, if you had some lithium, almost every atom of lithium is going to be this type of lithium called lithium-7, all right? So lithium-7 is the green one. All right. Now, there could be a different type. There's a different type of isotope. There are two types of lithium atoms, lithium-6. But whenever you dig up lithium, almost all the atoms that you find are going to be lithium-7. Very few will be lithium-6. They're slightly different. Okay, let's talk about how they're different. They're both lithium. So there's lithium-7. There's lithium-6. How are they different? Well, you can explain it using a Venn diagram. They both have 3 protons. They both have 3 electrons. But lithium-7 has 4 neutrons, and lithium-6 only has 3, because 3 plus 4 is 7, 3 plus 3 is 6. They're both lithium atoms, but they have different numbers of neutrons. Those are called isotopes. Okay, same atom, different numbers of neutrons. They're called isotopes. Because they have different numbers of neutrons, they have different masses. Now, because lithium-7 is way more common than lithium-6, if you look up lithium on the periodic table, okay, you would see lithium, you would see a 3 here, and you would see a 6.941. Now, this is called the average atomic mass. All right? Now, if you just average 6 and 7, you would get 6.5. But that's not what's on the periodic table. The reason that it's 6.941 is because the average takes into account how common or how abundant a certain isotope is. And because lithium-7 is way more common than lithium-6, the average is closer to 7 than 6. Okay, that's it for this video.